Chapter 10, Section 3. Objective, learn to calculate the probability of an event as a fraction, decimal, and percent. Essential question, how do I find probability using theoretical methods? We took this dice chart in class and we looked at the different sums that we can get from rolling 2 dice. From there, we went and found the individual probabilities of rolling each sum. The dice chart probability is the one in the middle column. We found our own probabilities from rolling 100 times, and then we found the class probability after we totaled them all up. What we discovered is that the class probability was closer to the dice chart probability than our own probability was. The reason for that is that the class did the rolling more times than we did, so we had a higher number of outcomes, and we were able to get a closer percentage. The dice chart probabilities are what are called theoretical. Those are what we anticipate to happen. So without ever rolling 2 dice, we can anticipate that 16.7% of the time we'll roll a 7. We need to do this experiment enough times to get those accurately close. An experiment consists of rolling a fair number cube. Find each probability. The probability of rolling an odd number would be rolling a 1, a 3, or a 5. That's 3 out of 6, or 1/2. The probability of rolling a prime number. Prime numbers, remember, are numbers that are not divisible by anything except themselves and 1. 1 is not included in the prime number set, so we would include 2, 3, and 5, which would be 3 out of 6, or 1/2. The experiment consists of rolling 2 fair number cubes. Find each probability. The probability of rolling 2 3s. That means we're rolling a double. There's only one way to roll double 3s, so it would be 1 out of 36. And number 4, the probability that the total shown is greater than 10. We would look in our chart and find all the different outcomes that are greater than 10. So we have 1 11, 2 11s, and a 12. So that would be 3 out of 36, which reduces to 1/12. Leon uses squares to make a board. He randomly throws a stone onto the board. What is the probability the stone lands on a space marked 3? When we're looking at probabilities, we need to have equal spacing. So the first thing we need to do is divide up our box of 3 into 4 equal parts, and our box of 2 into 4 equal parts. Now we have equal spacing to work with, so we can count up the number of 3's. 1, 2, 3, 4, 5, 6, 7, 8. Out of total, 4 by 4, which is 16, which would reduce to 1/2. Again, this is theoretical. This means what we would expect to happen when Leon throws a stone onto the board. Half the time we expect it to land on a 3. When the outcomes in a sample space have an equal chance of occurring, the outcomes are said to be equally likely. The theoretical probability of an event is the ratio of the number of ways the event can occur to the total number of equally likely outcomes. So our definition for theoretical probability equals the number of ways the event can occur over the total number of equally likely outcomes. A coin, number cube, or other object is called fair if all outcomes are equally likely. An experiment consists of spinning this spinner once. Find the probability of each event. From looking at the spinner, we have equal spacing, and we have 5 individual numbers. P parentheses 4 means the probability of a 4. So the P stands for probability. What's in parentheses is the event we're looking to occur or not occur. It would say not if we didn't want it. So we're looking to get a 4. There's 1 4 on the spinner, so our probability as a fraction would be 1/5. We need to be able to write decimals in percents. 1/5 is the same as 2/10 and 20%. Remember, to change a fraction to a decimal, we can either convert it to one we know, or we can divide 1 by 5. And to change a decimal to a percent, we multiply by 100. Now we want the probability of an even number. The even numbers on here would be 2 and 4. So that's 2 out of 5 numbers. 2 out of 5 would be the same as 4/10 and 40%. Let's use some coins to figure out probabilities. An experiment consists of flipping 2 coins. Find the probability of each event. We're looking for the probability of 1 head and 1 tail. So we need to think about the possible outcomes. We could get heads and heads, tails and tails, heads and tails, or tails and heads. So 1 head and 1 tail, we have 1, 2 options. So 2 out of 4 is 1/2, 0.5, 50%. Probability of both tails. Going back to our sample space again, we'll just flip back for a second. We're looking at this sample space. So to get both tails, there is 1 way. So we would say our probability is 1 out of 4. 1 out of 4 as a decimal, 0.25. As a percent, 25%. Lastly, let's look at geometric probability. Geometric probability is theoretical probability based on ratios of geometric lengths, areas, or volumes. Find the probability that a point chosen randomly inside the circle is within the triangle. Round to the nearest hundredth. So we're looking at the white triangle area inside of the purple circle. That means we're looking at the area of the triangle out of the area of the circle, or our sample space. So if we recall, area of a triangle is half the base times the height. Because we know the radius is 3, both of these extending from the middle would be a radius of 3, which is a total of 6. So 6 inches is the base, 3 is the height, half of that equals 9. Area of the circle, pi r squared, radius is 3. We get approximately 28.3, which we could also write as 9 pi. So we technically get a fraction of 9 over 9 pi, which would be 1 over pi, or we get a fraction of 9 over 28.3. However, it's not proper to keep a decimal within a fraction. If you end up in a situation like this, it's easy enough to just multiply by a power of 10 so that you eliminate the decimal. So because there's only one decimal place here, we can multiply both by 10, turn this into 90 over 283, and from here we could reduce if possible. The decimal for this would be 0.32, which would make the percent 32%. That's it. Make sure your notes are filled out. Do not forget questions on the left-hand side. Review your notes, highlight, underline anything that's important, and complete the summary before class.